Okay, so 6.2 is going to be exactly like 6.1 with this exception right here. They are not going to give you the population standard deviation, but not to worry, they will give you the sample standard deviation. So the trick for this section is not going to be anything different. I'll explain this degrees of freedom and how you can find your all of this by hand, but I first want to show it to you on StatCrunch because all you have to do, um, the hardest part of this or the most important part of this is being able to read these examples and first decide if this is a going to be a z interval or a t interval. That's what you have to decide. If it was 6.1 and they provide you with the population standard deviation, then it's a z interval. If you're doing 6.2 and they do not provide you with the population standard deviation, then they're going to be giving you the sample standard deviation, and that's when you use a t-test or a t interval. So you read the problem, you randomly select 16 coffee shops. So this is going to be your sample size. And that's how you know you're dealing with a sample because it's not all coffee shops, it's just 16 of them. And measure the temperature of the coffee sold at each one. The sample mean, and it very plainly says the sample mean, so that's X bar, is 162.0. With the sample, it very plainly says with a sample standard deviation of 10.0. That is your S. That's your sample standard deviation. Construct a 95% confidence interval. So our C is 95.95. For the and this is what we're doing right here is we're using all of this information to predict the population mean. It's just exactly like it was the last time. But this information right here, the sample standard deviation, this right here is how I know I'm doing a t interval. Okay, so that's pretty much all you need. You need all of this information. N equals 16. I'm gonna make that maybe a little bit smaller so that I can see everything while I am on StatCrunch. And then I'm going to go to StatCrunch. I've already got it open. You should have an idea of what we're going to do. We're going to go to Stat. We're going to go down here to, there it is, T-Stats. We're only dealing with one thing right now. That's the coffee shop temperatures. So it's a one sample. And again, they didn't give us a list of all of the 16 temperatures. If they'd give us a list of 16 temperatures, then we would put it in, we would select data and we would work the problem from there. Instead, they gave us the information about the data that they collected from the 16 coffee shops. So we're going to select that one, and then it's simply you're going to put in what it asked for, the sample mean. And this is where I hope I can get this up. The sample mean was 162 degrees. 162 degrees. The sample standard deviation was 10 degrees. And the sample size was 16. This is for another chapter. We are doing a confidence interval, and this particular problem asks us for a 95% confidence interval. So we're going to choose 95% confidence interval. I don't like having it store it in this table right here because it all runs together. I like it come up in a nice little window. I don't mind seeing it on the plot though, so I'm going to go ahead and compute. And it does the same thing as last time. It gives us the lower limit and the upper limit. And we go over here and we see here's our sample mean. The sample mean was 162 degrees And the low end over here is 156.6 degrees, and the upper end is 167. So that's what we have to write in our answer over here. So 156.6. So we're going to write, put open parentheses, 156.6, comma, and the other one was 167. Oh, that should have been 156.7. Round to 2 decimal places, we'll do that. 156.67 and 167.33. 167.33. 167.33. And what did I say that was? 0.67? 156.67 and 167.33. Okay, so there's the interval. If we are going to draw it's going to work the exact same way that the other one did. This would be our standard curve. If this is our x-axis, then we put our mean right here. Our mean is 162. It was a 95% confidence interval, so this is 0.95. The two numbers over here on the end are 156.67, and this one is 167.33. Remember, everything else is the same. If you needed to find your margin of error, you would find the difference between these two. So subtract these two numbers, or you could subtract these two numbers. This is the margin of error right here. Okay, if you wanted to calculate it by using the information from this up here, you can calculate it. Here is the way you calculate it. You find the margin of error by finding the critical value on a t-table. This is the first time we've used a t-table. I don't even have one open, so I'll probably finish this video and then open the other one and show you how to do it by hand or using the t-table. But you'd have to get the critical value from the t-table, and then you would multiply that times the sample standard deviation divided by the square root of the sample size. We did not talk about the fact that our sample size was 16, and that's not as big as it's supposed to be to know that we're dealing with a normal sample. But if you keep reading right here, it says for the population, assume the temperatures are approximately normally distributed. So they gave us the information that we needed. If our sample is not big enough, we have to know that the population is normal. And they're telling us right here to assume that it is. So just real quick, let's calculate the oh goodness, that's not what I wanted. Let's calculate the can I make this smaller? Yeah, I can. Let's calculate. We've got 162 is the middle. So subtract that 156.67 and you get 5.33. So that's your margin of error. E is equal to 5.33. You could have also done it the other way around. You could have said 167.33 and take away the 162. And that would have also given you 5.33. So the margin of error is 5.33. I'm going to go ahead and stop the video, and then I'll come back and show you how you could use the t-table. And then I will do a separate video for each of my two classes, one using the calculator, one using the 84 and one using the Inspire.